Hi, it's Mr. T here. In this series of videos, I'm going to go through how to answer exam questions so that you get the best out of your writing when you're sitting exams. If you find this video useful, don't forget to click a thumbs up, subscribe, and then click that bell for notification if you want to see the next video. Hi, in this video, I'm going to be looking at the NCEA Organic Chemistry papers, the Level 2 from 2021, 2022 and 2023. I've taken the questions out of that paper about how bromine water can be used to distinguish between unknown compounds, and I go over how to answer these questions in a way that will get you a really good mark. So I hope this is helpful, and yep, I'll leave it at that. Okay, let's look at some questions about how we use bromine water to distinguish between an alkene or a molecule with a double bond and one that doesn't have one. So if we can remember about the bromine water test, we know that bromine water is orange, and if it reacts with an unsaturated molecule, either an alkene or an alkyne, it's going to go colorless relatively quickly. So we're talking about 5 to 10 seconds while shaking. So let's look at some questions and how we might answer them. So this first question is from the 2021 paper. You can see the details at the top right. This is an NCEA paper. And they're asking, explain how you could distinguish between the following pairs of compounds using chemical properties. Include observations and structural formula of any organic products. Chemical identification is limited to the use of bromine water or potassium permanganate. Bromine water is a lot clearer to explain, and I'd always choose that over potassium permanganate. We remember that often we could use potassium permanganate here, but it would react with the alcohol and the alkene, so it's better to use the bromine that would just react with the alkene quickly. So what would we write here? Well, the first thing that we would write down is that pent-1-ene is an alkene. It contains a double bond. So it's going to undergo an addition reaction. Now remember, what's going to happen here is the double bond between the first and the second carbon will break, and we will add a bromine to each of those carbons. And we can draw this in our, let's draw this in the actual equation down here. You can see what I'm talking about. We need to state what our observation was here, and the observation was that the orange bromine water rapidly decolorizes. We could write it a different way. We could say the orange bromine water became colorless, or the brown orange bromine water became colorless when it is shaken with the pent-2-ene. Addition reaction. The other thing that we might say here is propane-1-ol does not react with bromine water quickly, as the orange color from bromine water will persist, or it stays orange. Now, one of the things that might happen here in this type of question, they might ask you to explain what type of reaction a propane-1-ol might undergo, and this is where you would say something about it would undergo a substitution reaction under the presence of UV light after about 30 minutes. But in this case, it's not needed because they haven't asked for it. They just want us to explain the positive reaction. And that's used as a distinguishing test. So basically, this will work really quickly with a double bond molecule, an alkene, and not quickly with anything else. So answer, did we identify the correct product? Yep, we've drawn that down here. Look, it's really important to make sure that it was a double bond, so I have to put 2 bromine atoms there, one on either carbon where the bond was broken, and distinguish one pair of compounds. So when it says one pair of compounds, this was a multiple question, and bromine water was just part of it. But we have distinguished here the propane-1-ol and the pent-1-ol, and we've talked about the observation and the formula involved. So we've got both achieved in the merit point. Let's look at the Right, okay, so here is 2022 question 1. Again, you can look up the paper. If you go to NCEA, just chuck in, or if you go into a website search engine, you can just chuck in NCEA and the standard number and the year, and it will give you the paper. You can print it out and go through this with me. So I need to compare and contrast. Oh, sorry, here. Compound C is reacted with bromine water. It reacts differently to the other compounds. So here's compound C. Notice here that it has all the carbons in a circle, but no double bond. Compound A, B, D, and E all have a double bond. So we know that the bromine water is always going to be either reacting with something with a double bond and something without the double bond. I have to compare and contrast, so this is likely going to be an excellence answer because it's using these words compare and contrast. The reaction between C and all of the others. We need to justify the types of reaction taking place. Okay, so, and state any conditions required. State the expected observations. So, compound C is saturated and does not contain a double bond, where when bromine is added and shaken, the orange remains. So, when they're saying name and justify the type of reaction, we could actually go through and do a more robust explanation in this case because we think it's going to be an excellence answer. So if it's left, I'm saying if the solution is put in UV light for 30 minutes, it will decolorize. A substitution reaction has occurred. We have to describe the substitution reaction. So we go on and say a bromine atom replaces a hydrogen atom on the molecule. A bromine atom replaces a hydrogen atom on the molecule. The next thing that we are going to talk about is the other four, and compound A, B, D, and E are all alkanes and contain a double bond. When it is added and shaken, the bromine water rapidly decolorizes. These undergo an addition reaction. Now we have to explain exactly what does an addition reaction mean in this case. So the addition action is where one of the bonds of the double bond breaks and then atoms are added to the carbon of the double bond. So we'll get two bromine atoms added. So if I was going to then give an answer for this or check the answers, look, if I identified the two types of reactions, I get a mark. If I state the color change is correct, I get another mark. If I explain the type of reaction linked to observations, so if I basically put both of these down, I'm going to get a merit. But if I go into detail and say what a substitution is and what an addition reaction is, that's what gets me the excellence grade here. Okay, let's look at the 2023 paper. We can see here that we have two molecules and they want us to distinguish between the different products of these two reactions using bromine water. So we're going to describe how we would carry out the reaction here. So as an alkene, we're going to say this one is an alkene. It contains a double bond. When bromine water is added, it undergoes an addition reaction. The orange bromine water rapidly decolorized when added and shaken with pent-2-ene. And we get this reaction here. So I guess the first step here is to say that we add the bromine water to each of the samples. Then we've got this explanation that we get an addition reaction. The orange bromine water rapidly decolorizes. I mean, it's pretty standard. This is what we've gone over the other ones. This is a bit more simplistic. I'm not going into detail on how the addition reaction works because it just wants me to explain, not to discuss or compare and contrast, which are actually more higher level explanations. Propane 1-ol does not react, so this one here will say does not react with bromine quickly, and the orange color from the bromine water will stay or persists. Answers. If we wrote the correct observation for one of these, so I said even the last bit here, the bromine water persists, and I get an achieved mark. If I link the observation to the compound reacting to distinguish the product, so if I talked about the bromine water is changing color when we add it to the pent-1-ene because it is undergoing an addition reaction, we're going to get the achieved merit mark here. Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.